Failure-resistant pipeline steels are of great importance because they are used to transport oil and gas over long distances, and they would be used to transport hydrogen gas in the future hydrogen-based economy. So our top findings so far shows that the initial size of cracks in pipelines, although they are important, they are not as important as the rates of the propagation of these cracks. That is, how fast these cracks grow, especially under stress. This crack propagation is largely dependent on the amount of hydrogen ingress into the steel and how much of this hydrogen is retained and where they accumulate within the steel. Using the high energy synchrotron radiation, we were able to map out the 3D cracking behavior of these pipeline steels. Here we were able to understand the cracking, initiation, and propagation behaviors of these steels. We were also able to relate these behaviors to the microstructure of the steels and the hydrogen accumulation behavior of these steels. And if we want dedicated pipelines for pure hydrogen, we need to understand this relationship.